Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Sure. Go to Hamfest, they say. You'll find all kinds of good deals at Hamfest. And then you go and you find your buddy. Happens to be Mr. T. That's as far as we're going to go with it. And as you're picking up an amplifier off his table, his parting words are to you, "Oh yeah, you're going to have to make a high voltage pin connector for it." And you're like, "Why?" And you're like, "Well," he says to you, like, "Well, dumb little so-and-so over here who walks kind of like he's only got 2 legs, but he's supposedly got 3. He squats like a fart bag, and he was walking with this thing and ripped the high voltage lead completely off the thing. 25 minutes later, smoke pouring out of both ear holes. Oh, son of a bitch. It's okay. It's a small price to pay. Oh my God, I got a hole. I got an open hole down in her hole. She's feeling so low. It's all right. This is like starter wire or some shit. I don't know what that's all about. It's okay. They're not even the same Bakelite colors. I'll reach over here. Now should we do... What should we do for silicone wire? Should I do that? Or should I do this? Should I do this? Should I be silly about it and use that? Should I even be more silly and use a little bit bigger stuff like that? Or should I use magic marker wire? I don't know. 3,000 volts. 3,000 volts. Yeah, let's use the 100 kV magic marker wire. That's what I want to do. So, jacket is deceiving. Look. Little wire, fat wire. Stupid expensive, hard to find. Super cheap everywhere and works great. We're going to go with this little stuff. We're going to go with the little stuff. It'll be okay. No one's going to complain. Swear to Christ. Swear to Christ and holy Jesus. And then what we can do is we can put that inside of a piece of nylon tubing to keep our customer from getting electrocuted, because this is a 2-part amplifier. It's okay. We're not judging. We're not pointing any fingers. We're not laying down no guilt trip. We're not trying to make anybody feel bad. We're not cupping and farting. We're just going to walk away. We're just going to walk away. I thought it was funny, because he had this guy that was with him, and he was a knuckle dragger, like mongoloided ape, covered in tattoos. Big dude. I don't know if I'm a pretty big kid. I'm 6'5", 4.5, whatever, 300 plus pounds. And I looked at this guy and went, he's one of me. Fellow semi-Neanderthal individual, right? And the guy that owned this amplifier was sitting there talking smack about him, like, "No, you're son of a bitch. Couldn't freaking walk up a set of stairs without ripping a high voltage wire apart." And, but then he seen who was buying it, because we were teasing each other a little bit earlier in the day. We were talking about a a thing that went down with some other people, and a thing and a thing and a dog and two cats and a mule. And he just looks and smiles. He goes, you know, it's missing his high voltage wire, but that won't be no big deal for you. I'm like, oh shit, thanks. So here we are, day late, $1 short. 6 dicks for Sunday. Or wait a minute, what was that movie? 6 dicks for Marianne or something like that? I don't know. It played right after that time I watched Saving Ryan's Privates. It's kind of interesting. Anywho, so here we are at the end of the story. The beginning of the tale, and oh, only the beginning of this video. Gentlemen, sit back, relax. We're going to have ourselves a good time here. This amplifier was worked on and repaired by a friend of mine, or somebody I'd like to keep as a friend, so I'm not going to sit here and talk massive smack like, oh my God, what were you thinking when you wired this? We're going to have a good time. High voltage manufactured wire. That's a 3,000 volt wire, or no, 6,000 volt wire with an actual virgin Teflon outer jacket armor on it. So if you manage to break that, hey, congratulations. You've proven your manhood to all of us. So guys, this is the DX2000L. It's a 2 kilowatt linear amplifier made by RayTrack Company. Never even heard of these guys, but it's a 3500Z box, is a 3500Z box, is a 3500Z box, and Mary's got the clap. Okay. It's all basically the same thing. We're going to put roughly 3,000 volts on the anode. We're going to have X amount of volts on the filament, the same of like every other 3500Z box in the world. The only difference is this is a two-piecer like a Drake. Like the infamous L4B, but not constructed like the L4B, but it's got really good scooching good parts in it. Honestly, between you, me, and the hole in the wall, I think this might have been known by an 11-meter guy at one point. Since the band selector on the input side on the 10-meter side is a little scooch, but has been repaired by a professional baiter. Professional baiter. Master baiter. Anyhow. I highly admire this mod. This is friggin' kick-ass. I love it. Let's zoom on in here. At least we got diodes on the back of our meters. That's a plus. And that is a plus. Show a little dusty. Just a little dusty on the inside. It's okay. We're going to get in here and we'll knock Jesus dust off of this thing. If I didn't know better, I'd say that this is some kind of horned up styled SP220. But the main reason behind the horn cap that's on the filament transformer here, hold on, let me change angles. The primary reason that we have horns on the outside are these caps that sit on the outside of the transformer like this is to help keep the RF out. So as the wire is making its turn around the core, if you don't have this horn cap on it, you've got to actually wrap this thing in metal. See, this is our RF deck. Here's our 3500Z scoochums. We got to wrap this transformer metal, even though it's got a physical isolation with the filament choke on the bottom side before it feeds the tubes. You can have wild fluctuations in the voltage coming out of the bottom side that are going to be affected by the RF that's on the upper side of this deck up here, the amp portion side of the deck. So to help stop that weird inductive signal that takes place there, they put what they call a horn on the outside of the transformer. If you didn't know it, now you know it, and no one's half the battle. G.I. Joe. I appreciate this. This is simplicity, but imperfection in the same breath. I'm assuming these are 12 volt LEDs or 12 volt green and wheat light bulbs. We're going to find out for sure here in a few minutes. I say I assume because we can very clearly see down inside of here that we've got some kind of resistor underneath this heat shrink, and it's on the positive side of the circuit. So This thing is a squirrel cage, forced air cooled SB220, which is cool because it allows us to have great amounts of key down time. Instead of having air that is blown from the backside and wraps around the tube, we get to cool the pins. We're going to cool the socket. We're going to cool the attachments to the socket. And then our exhaust gases of our chamber are going to vent up through these bells, these Pyrex bells. They're going to wrap around the full body of the anode, and then they're going to hit the tops of the tubes. Now, I look at these little tiny anode caps and I think, oh, they're so cute. As in all 3500Z videos, we're going to take this opportunity to plug RF Junk. Gentlemen, go to rfjunk.com for all of your oversized anode cooling cap needs. Professionally made here in the United States with American sourced metal, and of course manufactured by an actual American, not Chinesium components. He manufactures multiple different kinds of anode cap dissipators, heat dissipators. That's one version that he just sent me to play with. And let me grab the bench test 3500Z tubes. This is my preferred beast of existence. rfjunk.com, gentlemen. Just saying. I got to give my buddy a plug. They're a good product. I receive absolutely nothing in return for this plug other than to say that I did it. So I think a set of these are going to be going with that SB220 that I'm getting ready to build. That virgin out of the box SB220, by the way. So here is our output tank coil in the back. The input inductor circuit and the output inductor switch are tied together by a chain drive, which is some cool tech. Flip this around so we can take a closer look at it together, you, me, and everybody else. Semi-sealed contacts, way heavier duty than the SB220, somewhere around the 922A kind of format. Like I said, this is a two-piece unit, and I was in it just a little bit ago because the ground plug that's on the back here was a little loose. I want to make sure we had that tight. And here's the questionable bit, is the secondary portion of this, the power supply that goes into this. Not a little sure about the tech that's going on inside of there. I feel fairly comfortable about this stuff here. The tubes are a little bit dark, as in like I think they're dirty. But I looked and I looked and I squinted. I put on my old man goggles and looked really close. I noticed, old man goggles, I noticed that if I was holding the tube up to the light and I rotated it away from me, I could see some writing that was in English. So at least know they're American manufactured 3500Zs. They look like iMac design. Can't tell you that for sure. We'll pull both tubes out here in just a little minute in the next segment of Bajeo. We're going to set this aside. Let's bring the power supply up here and see what we got to do to bring this up to actually safety snuff. Eventually, someday I'll get good at what I do, I swear. And then they're going to admire me through all the land. All the land. They're going to sing tales about me up in the mountains. They're going to be like, oh, BBI. He was an arrogant prick, but he knew his amplifiers kind of like he knew his own. Not going to fill in the last word because that would get me demonetized. Just saying. Okay, so we've now rotated. This scoochum is slipping. Well, we'll tighten. We'll put the power of the ginger Jesus on you there, and we'll get that bent around. Okay. Kind of glad we did that. Otherwise, that would have made contact with this resistor, which would have been bad because this is ground. Anyhow, like I was saying, let's take a look at this. We can see there's a little bit of burn mark. On a serious note now, guys. Switching gears. We're in an 80 meter position, okay? When we rotate this around to 11 meters, that's when this portion of this kind of gets called into happiness here. And this has all obviously been rebuilt. But this is very adequate. This was a good job. I feel comfortable about this. I'm going to leave this alone. We'll only revisit this if we absolutely have to. This doesn't look teabag. This is our glitch resistor, or glitch choke, by the way. This is our final output stage. Somebody took a lot of time and energy in wrapping that coax and soldering it. They were very delicate with their soldering iron, taking into account that's foam dielectric. What they did is they brought the shield up, they trimmed the shield off, and then they took a piece of wire and very carefully wrapped it around the shield, and then very carefully soldered to that wire and didn't deform the inner insulator. And I'm sure this was done before I was born, so I'm not going to worry about that either unless it presents to be a problem down the road. Okay, let's go ahead, let's switch over to the power supply now, and let's see what Uncle T did for us there. And the Lord said, BBI, have a hernia. Okay. So first off, I don't feel too comfortable about this base plate. This is our high voltage lead right here. So I'm going to need to fab up a bottom piece for this. It's okay. I think I might have a guy that knows a guy that maybe touched somebody sometime down the road and got married and had kids, and then here we are. Who knows a dude that's got some aluminum. We'll fab up a bottom piece for this. It's no big deal. This is our 110, 220, probably our 220 options. And here's our fuses. Now what's got me kind of interested is what's in this hole. I know you guys want to look with me. Let's go look together. Let's see what's inside the hole. Oh, self-tappers. Only the best metal products are built with these. I joke. This is actually a very well-constructed cabinet. Very thick metal. I'm going to feel perfectly comfortable shipping this across the country. Let's see what we got. Survey says, ding, oh, look at that. Oh, commercial rectifier unit. Decent capacitor bank. Contactors. Oh, somebody cared when they built this. Nice. This makes me happy here. Contactors for our high voltage circuit. Real cap bank using electrolytics. I like the submerged diodes. That makes me happy. Nice air lit, good ventilation space. So, I think this is out of some kind of Henry unit. I don't care, as long as it produces the amperage. And I'm here to tell you, if this little piece of iron can't produce enough current to run those little two tubes, there's something wrong with America's engineering back then, and I'm pretty sure we had it figured out. So, let me slap this back together, and so you guys don't have to listen to the impact hammer no more. I shall return. first we put down this stuff. This is called T-Rex tape. It's a variant of butyl. Okay. T-Rex is just the name that's on the inside of the roll that I currently have. I think you can actually buy this style of tape at Harbor Freight, of all places. But this is waterproof, heat-activated, epoxy-based electrical tape, good to 850 volts. Since it's impossible to take this plug off, and we've got to reinforce this plug and cover up our bare wires on the back and provide some kind of torque support to the plug that's on this thing, we've also got to support our unjacketed wires. Well, I'm not a big fan of 600 volt, 3 mile an hour tape. This shit. Fuck all about that. So what I'm using is, once again, 650 volt 2-part marine epoxy heat shrink, and I just shrunk it down around the plug just to hold it in place. Now what I'm going around and I'm doing is I'm putting this high temperature activated epoxy based electrical tape on here to keep the water out and to keep the wires more stable. And then I'm going to come along and I'm going to put nylon based spiral wrap over the top of this as an extra impact guard, otherwise generating the same amount of impact resistance as the jacket. And then we'll go ahead and we'll close our heat shrink up around that too. Give it a little bit more professional fit and finish. Okay, so now what we're working on, guys, is the ground wire they had going from A unit to B unit. There's this little piece of 22 gauge Teflon stranded silver coated shit. And I'm excited because I'm getting to use my gator grip. My wife was giving me shit. She goes, I bought you this gator grip like 5 years ago. You ever gonna use it? And I decided I'd give it a shot. I told her, baby, I don't know. I don't really even consider that a real tool, to be honest with you. I mean, it looks like a tool. It's shiny. It's got pretty bits on it and stuff. But okay, so what we're going to use is a piece of 8 gauge wire with soldered eyelets on it, so we don't have to worry about nothing coming apart. So, like, have you guys ever noticed you got there are 2 standards in this world? You have that standard that you're going to put together for if you're going to let somebody else have a piece of equipment, versus the standard that you're going to have if it's just going to sit around your shack and you're like, oh, piss on it, I want to see if it just freaking works or not. Believe it or not, those are 2 universally accepted standards. Yourself safe, and then what you're going to do for somebody else safe. So unfortunately, I don't want this amplifier. I don't care where it goes. I don't care who ends up with it. It can't stay here. So for me to let it go out the door, any parts that I put on this, I'm accepting all the liability for it. So thusly, let's talk like the guy from the Matrix. Ergo, the calculation of the tabulation of the fart of the Matrix says that I have to have this up to a certain standard, which means I have to have a strike resistant plug that is flex resistant at our attachment points at the joint for the plug. Believe me, guys, we're going to let this amp go for a steal. We're going to really, this is just going to go away. So we're going to give ourselves a little bit of strike resistance at the plug. We're going to make sure that we provide a good ground wire between the power supply and the main unit. And then we're going to hook ourselves up with double safe high voltage lead that goes from A to B for a reason. I'm not a big fan of these units that don't have a meter in the power supply. If the meter in the amplifier fails, it's one thing. If the power supply is inside the amp and the meter fails, it's different. But when you have connections that are like this externally on something, this is scoochum dangerous. If the meter in the amplifier unit itself fails, you have no other means to know if there's voltage still on the supply or not. Yes, there are bleeders there, but it's inherently very, very dick schmack dangerous. That, and guys have a tendency to forget that there's sheer death on the other side of this plug. I mean, literal instant freaking blow your penis off, you're gonna die. Death. And so when they're back there checking all their plug connections on the back side of these two-piece amplifiers, they automatically reach over and they grab that high voltage connector, not knowing that millimeters away or one little crack in the Bakelite plastic is death. I hate two-piece units. Freaking hate them. But in the same breath, people seem to be somewhat comfortable with them. So I don't know. Me personally, from a personal point of view, I built one two-piece amplifier. I regret it to this day. I've always controlled where that amplifier went and the people that owned it, and will continue until I die. Everything I produce from this point forward is always going to be a one-piece 4 model. So, anywho, let's drop this down on the floor and let's insert balls deep and hit it and quit it. So I go to run this and I had no filament, as in the tube wasn't lighting up at all. And so I said, well, instead of us freaking out about anything, let's just go and look at the obvious. And one of the things that we noticed was the filament leads, after we opened the RF deck, weren't even attached. So it was a little questionable, because of the quality of the solder work on the filament leads, where what went. I didn't know if they were just using a single side of the filament, and so I had to meter that really quick. So what we're looking at is both poles of the filament is at 6.3 volts, which I'm sure under load that'll drop to be more within a 5 volt range that we're used to seeing. So our high voltage circuit is working, and the meter is working for it. We can see that with our bleed down process that's going to take place here. Over 3,000 volts, like 3,100, 3,200 volts, which is good. Just a small little issue on the inside, and I think that we're going to be able to get this figured out. So as that goes ahead and it bleeds down, I don't need to have that on anymore. As that goes ahead and it slowly bleeds down, we're going to come in here and we're going to fix this here. And instead of having these just surface hooked, we're going to actually hook them through the eyelet, which is on this bracket. There's a bracket here. Let me pull this test lead out of the way and pull this test lead out of the way. I'll go ahead and desolder this. That one's desoldered. And we'll make it so our leads fit thoroughly through the hole. Probably tie them with some other exterior copper wire to make sure they can never come off. We'll hook them. Hook them. Hook them and book them, Dano. Just like that, so they can't wiggle free, and we're not going to have this issue ever again. And we'll flip it back over, and I feel fairly comfortable that this thing's going to take off. The only other thing that brings me any reservation is this little diode that's hanging out here in free space. We've got to look a little bit closer at that circuit. This is all tied in with the ALC circuit and then the keying circuit. So this whole board, and this diode looks like it's supposed to attach here, but that's part of our center tap for our filament. I'm going to come back to that. I'll pretty much print up some labels on the back, and Bob's your auntie. We'll be back. Give me just a minute. Okay, well, our filament leads are all hooked up. And while I was in there, I made the visual observation that the filament choke was the filament choke, the actual rod itself, was floating free inside of the winding. So I went ahead and I epoxied that in place, soldered and hooked. So I have a mechanical connection on the end of our filament leads. We don't have to worry about that coming off ever again. That's by some miracle it manages to get to 65 million degrees, even though we've got the blower basically blowing right onto this. So let's get this sealed back up. I want to flip it over and see what it does. I feel relatively confident this is going to work now. Okay. So over here we got a 1,000 watt slug and peak, 1,000 and average, 5 watt slug and reverse back from the bird, 10,000. Well, it's currently orientated forward, and that's so we can help find our tune. Remember, you always start out low. You don't just go and dump a bunch of watts in this thing and go to tuning, because if the RF can't come out, you're just damaging the tubes. So 50 watt slug and reverse, and then over here off screen, get a little bench 2-pill. Got our nice little small 3/16 coax going in between everything here, and then on the output we got our G400. So that's going to be our on switch. Tubes are now lighting up. That's a significant improvement over no lighting of tubes. Before we bring our high voltage on, we got good airflow. Let's bring our high voltage up. So now, we show that we can talk through the box. Hello. Hello. Our 20 watts over here in peak. And then we're going to show you that we're going to put 1 watt into it. We're not seeing any reflect on our 50 watt slug that we've got in reverse here, of course. So let's go ahead with our 1 watt. Reach down here. Now this is important, because whoever ends up owning this thing is going to need to know how to put it in operate. We pull this knob out. This knob. It says ALC, this is your ALC adjustment. Automatic limiting control circuit. That's this direction. The OPT and standby is that center knob. Oh, already making power. Okay. So we're putting 1 watt in. Now we're getting 5 out. Hello. That's strong. Okay, so 1 watt carrier in. Let's make it about 10 watts out. I'm going to turn this around. Now we're going to tighten in on this slug here. Hello. Hello. So we're 20 watts in, getting 30 watts out. That's pretty good. 20 watts in, getting 300, watts out. Let's see here. Hello. That is actually moving. Relative power, I think I got the knob turned down in the back. Okay, so let's turn on our little 2-pill. So now we're going to dead key 20 watts. Hello. We're going to swing about 200 in it. But first we're going to start out with a little bit of a carrier until I get to know the box a little bit. So put 80 in it. Come off the key, let our tubes cool down a little bit. All right, back our dead key down a little bit. Hello. And it's gone. Hello. Plate meter's working, everything's working good. Okay, so come over here, take that up to 2x. So now, as we all know, covered in many thousands of videos, full deflection on the meter over here is 2,000 watts. Our halfway point is actually over here at about the 1 o'clock position on the meter. Straight up and down being noon. 1 o'clock's 1,000 watts. We're looking at this in peak. Let's take a minute and we're going to go over here and we'll look at our reflect meter. Not great, but not too bad. All right, let's peek this thing out and see what we can get out of it here. Hello. Hello. let our tubes cool down for a minute. So we're seeing about 1900, 2000 watts out of this little guy. About 210 watts worth of drive. Which isn't teabag. It's not the greatest in the world, but it's not too bad. Let our tubes cool down from being in outer space heat. Hello. I like the blue. I'm not gonna lie, I really like the blue. It reminds me of looking at Vader. There's zero signal. See where grid meter's telling us. Well within safe range. So everything works just the way it should. Let's see here. Why you know worky worky? I'll replace that light bulb here in a minute. Never had any real success in taking them out without breaking the bulb. I'm not gonna lie. So it makes me happy. Everything on this is pretty much straightforward. So the only thing I got left to do is I need to document this thing working on all the other bands. That, and I want to repair the AC on light, which I'm pretty sure all that's going to require is a new bulb. So give me a second, we're going to reconfigure this. After a great deal of twiddly farting around with this thing and having to completely change how the lamps are wired, this is your standard incandescent 110 volt bulb, right? That's not what these sockets are. They look like it, but they're not. When I was trying to trace the wires back, I finally was able to figure out that this has got GE glow lamps in it. These guys. Now I had a guy send me a box of unobtainium bulbs. I didn't have him. He offered and sent and donated for free a box of unobtainium bulbs. Well, over here on the AC side, even though this bulb was in op, it wasn't even hooked up, the wire wasn't even hooked up. Even though this bulb was in op, because it had a lamp in it. Okay, a light, actual physical element. The thing that makes these so cool is there's like a 50K worth of resistance on the shield for this neon element. That's an actual little neon element that's in there. There's no, this thing is full of a little bit of gas, and there is no physical whatsoever filaments that go between the two. Well, when I seen that high resistance, I went, oh, son of a, because I was trying to make it work with a light bulb. I thought, man, am I gonna have to replace these sockets? Then I measured the resistance. Now, I made a special tool because I got tired of trying to twiddly fart these things out of here. I took a pen and heated it up and swelled it up to the size of the tube. Oh yeah, let's drop one of 4 bulbs that are known to existence in my shop. And let's do it again. If that isn't testament to how tough these little bastards are, I don't know what is. I dropped it on a cement floor. Pick it up. Let's not be so flippant with it. It allows us to smoothly insert and extract our light bulb without too much drama. So, life hack number 7,550 brought to you by BBI. Just simply heat up the end of a straw or a pen and swell it up so it's just big enough to grab the light bulb, and allows you to have enough torque to get it to seat and unseat and remove it. At the end of the day, after 5,000 flipping it back and forth, I had to change our high voltage lead. The high voltage wire I had was a little bit too stiff, and after about 4 or 5 turns with the high voltage wire attached, the high voltage Molex connector, I do believe is what they're called, snapped off right at the wire, and we were right back where we started. So I went ahead and I fought and fought and fought and fought and fought with this Teflon tubing and got a super high strand count, high voltage insulated wire to get through this nylon or this Teflon tubing. And now we've got neon bulb. Look at this, it's a completely different color too. My fellow ham operator guys out there are going to be like, oh yeah, we know all about that. I'm not too hip on this 1960s tech yet here. It's really quite cool. Really quite cool. So I'll put this lamp cover back on. That was a lot of fun. Justifies a few hours worth of work, but it's now all electrically correct and put together solidly, so we don't have to worry about it coming apart in the future. These are GE glow lamps, just so we have it as a model of record. CG610-DXs. They're the NE51s. 105 through 112 volt clear. I gotta order me more of these tonight. Hopefully I can find somebody on eBay that's got a ton of them, because I want to get a couple more. But they only work with a certain socket. That's the other trick. Okay, so let's see, where did we leave off? Oh yes, we're going to demonstrate this thing working on all bands. Okay, so show the radio, show the frequency. Radio, frequency. Show the amplifier. We're in 80 meter position, 80 meter indicated. And I found for some reason it's tuned a little bit lower than what is marked on the face. It's okay. So now we're going to show our input or our output power. Let's go over here. So we're going to show power going into the amplifier. About 60 watts or so, 80 watts or so, whatever. Hello, audio. Hello, audio. Nice strong 900 watts. Our input reflect. Hello. Perfectly low on that meter. Hello. Good on the input SWR meter on the amplifier. Okay, let's move on to 40. So here we are on 80 and 40. 40. And it's falling right on its mark here. It's pretty close to its mark here. Let's go up here, let's show the radio. Okay. Hello. Input SWR. Hello. Actual meter that we can believe. Hello. Output power. Hello, audio 12. Working just as advertised. Okay, let's go do 20. Okay, here we are on 20. Once again, input hit the pedal, Luke. Hello. Not too bad. What's the radio show us? Hello. Nothing, of course. Let's get back over here. Hello, audio 12. Hello, audio. Nice smooth 900 plus. On to 15, the most unused band in the world as far as I'm concerned, but I could be wrong because I'm wrong about everything else. Okay, let's go find 15 meters. A little bit of whoop whoop. Give me a little bit of whoop whoop. All right. So here we are on 20. And just for our mental well-being and notes, we're going to note this is at about a 4.1. And this is sitting at about a 6.4. Hello, 1 2 1 2 1 2. Hello. Hello, 1 2 1 2 1 2. Hello. Hello. There's our input tune. Hello, 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 hello. Nothing to write home to mom about. Hello, 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 hello. Still a 1.5 or lower on the input tune. And sure, for teabagging and grins, we're going to kick this over to the 10 meter position and let's go find it. Alrighty, the actual 10 meter position. Let's go on up here and we're going to do this for our own mental well-being. We're noticing that we're at about a 3.1 and a 7.9. Let's go over here. Hello, audio. Hello, audio. Hello, audio. Hello, 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 hello. Up to the radio once again. Oh. Trying to pull a fast one on us, BBI. Hold on. Because I had a guy literally about shart his shorts who went ballistic. Because you're not dead meter in the middle of the band, so therefore all your data that you just presented in the video is pointless. I was like, oh, my captain, I'm so sorry. Please forgive me. How dare I try and pull such an aversion upon the radio world? I was only like off by like 100 kcs or something. It was stupid. Okay, dead meter in the band, middle of the band. Hello. Didn't change the output potential, not one drop, no $1, not 1 watt. Doing exactly what it's supposed to do. So, what do we learn from this little experiment? That the DX2000L is an awful lot like the Drake L4B. I mean, like, crazy amount like the Drake L4B. But there's some vast differences. Whoever ends up owning this little tough guy, do not forget that's your operate and standby button. Right here. No, this does not have anything fancy in it like a QSK vacuum relays or any of the other silly little mods that guys like to have for doing CW and stuff. Let's go ahead and shut our high voltage off. This high voltage lead, this entire video has been like right next to my wank. Like it's been like this far away from my wank and I have not felt comfortable about that. So to shut that high voltage lead off makes me very happy. Let that slowly bleed down to 0. Now I am going to go ahead and fabric cobble a cover for the bottom of the power supply. This does come with a very, very nice case that slips over the outside of this thing. It's held in place by 4 screws in the back, or pardon me, 6 screws. And we do have rubber feet going on for this guy to help keep it up off the desk. Remember, this is a bottom ventilated amplifier, so it's going to pull air in from the bottom, and it's going to drive it up through the chimneys. Up through the chimneys. So, at the end of the day, everything works. Works exactly as advertised. Now, we're going to let this one go fairly cheap. We're not in this for a whole lot of money. We're not. I've got 5 hours or 6 hours into this one to where I feel like it's comfortable for me to let it go. I think we're going to let this one go for like $1,300. I feel very confident that those are actually just old iMacs that are in the back. This is a good little old box. It's been beat around the block. There's a lot of heavy modifications that have gone on the inside, but if you're looking for something that does all the bands, if you put 200 watts of drive in it, it'll make the full 2,000 watt output power. This is your job. I mean, this is going to get you 2 kW pretty much all day. And with it being blower cooled and chimney stacks, I'm impressed with this little bastard. I really am. Gentlemen, I'm going to run away. I think tonight I get to start on that 1 Henry that's down there, and I don't want to do it. No, oh no. I gotta go finish the 16 pill that's over here. I got a really cool 16 pill I'm getting ready to build. It's biased. At least we're gonna try and make it biased. So we'll see how stable it runs. Guys, I'm gonna go. Whoever calls me, texts me, gets to me first, gets to have this beautiful little gem. Remember, we got to calculate in some shipping for this. Power supply's got to be crated. There's no ifs, ands, or buts about that. This will be going through my logistics company that I have, so you're probably going to be looking at an additional $250-ish to $300 for shipping. Keep that in mind. I will find some place on this amp to stick a BBI logo. Have faith it will be there. Call me, text me, reach out, however you got to do it. Yeah, and I think I'm going to leave the comments open on this video. I think it'll be a lot of fun for you guys to sit there. No, you know what? No, I'm not. I don't have enough time to interact. Believe me, it's not a thing of running from criticism on the comments department, you guys. It's so many different avenues for people to get a hold of me. I have to control that. Between the phone, the text, email, okay, Facebook, Snapchat, Instagram, there's a lot. I leave the comments open. I feel like I have to read them all. So it takes up 30 minutes of time each day. And then if I sit down and I respond to 15 people, that's another hour that takes away from the workbench. That's the reason I leave the comments off. I just don't have time to interact with each and every single person on every level that everybody reaches out to me. Or, because there's going to be that one guy that says, man, that guy's a dick. I made a comment on his video and he didn't bother to reply. There's the same guy that decides to call on Sunday at 3 o'clock in the morning and gets all pissed and butthurt about it when I don't call you back on Monday. And then I ask you, please don't call me on Sunday. My one day of the week I take off. It drives me nuts. All my friends, all my customers, everybody knows I'm off on Sunday. I don't get it. Anyhow, gentlemen, big thanks to all you guys. Lots more fun stuff to come. Have faith. We got a lot of cool shit lined out. Bump from the biggest duck in Idaho. I'll see you. Bye-bye.